Estimating regression parameters. Now, basic description of estimating regression parameters is this is basically a statistical tool we use when we have a large data set. Now, when we look at the data set, we want to be able to predict an outcome using a regression line. Now, in our plot that we were going to get, you're going to have an independent, or two variables or a couple more variables. Now, that slope we can get, that's what we're going to use to draw a conclusion for future references that can help us in our fields. There's multiple different regressions that we could calculate. There's the least squares method, non-orthogonal, and orthogonal bases. Now, in my scenario, since I'm an electrical engineer, I want to relate it to power consumption in a specific city. So my two variables I chose were time and power consumption. Now, there could be other variables that I can use, like development, area growth, population growth, stuff like that, but I'm just going to keep it simple. In our graph, you see that there's a trending line up, but we didn't do any calculations yet to see what that slope will look like, but we know that the power consumption is going up. Now, to find the actual equation, we want to use first equation. We're going to have a regular slope equation, y equals ax plus b, which is x is the slope and b is a intercept. Or we can use the second equation, y bar minus ax bar, where we're going to use the mean of our data set here. Now, this is just a random data set that I got, just putting together numbers in a specific city, where x is maybe area and then the power consumption. And then we're going to have the y bar, which is means, and then x bar, which also means, and we use that to get an even more great slope. And we're going to use this data set to get a general least squares method equation. Now we're going to look at our calculations. Using the equations from our past slide, we're going to want to calculate a line regression line that best fits our model. Now, when we do this, we're basically minimizing the error of our graph for the best and closest possible estimations. Our estimations is what is not on or what hasn't been gathered as of now. We want to predict for the future. So, because it wouldn't be efficient. I mean, a lot of time consuming to go every day, every year, and calculate the power consumption from every house every year instead of using estimations. Estimations will make our job way more easier. And this is the whole point of line regression, is to make our job easier and use estimations. Thank you.